Hello, calculus fans. All right, we're going to try to calculate this limit. So the limit as x approaches 1 of log x over x minus 1. So let's say that f of x is log x and g of x is x minus 1. So that's the numerator and the denominator. Notice that the limit as x approaches 1 of f of x is equal to 0, and the limit as x approaches 1 of g of x is equal to 0. So that means our limit laws don't apply because we would end up with a 0 in the denominator, and we don't know what to do with that. And a similar problem crops up with this limit. Limit as x goes to infinity of e to the x over log of x squared plus 1. Both the limit of the top and the limit of the bottom are infinity. So we're going to call these indeterminate forms. The first limit is of type 0 over 0. Notice that I don't want to say that it's equal to 0 over 0. Nothing actually equals 0 over 0. It's of type 0 over 0. The second limit is of type infinity over infinity. Now there's a theorem that helps us to compute these types of limits, any limit of these indeterminate forms. The theorem is called L'Hopital's rule. So it just says that if f and g are differentiable and g prime of x is not equal to 0 on an open interval that contains a, although g prime of x does not have to be non-zero at a, and we suppose that the limit is of type 0 over 0 or infinity over infinity, the conclusion of L'Hopital's rule is that the limit as x approaches a of f of x over g of x can be computed by the limit as x approaches a of f prime of x over g prime of x. That's provided that the new limit exists or is infinity or minus infinity. Notice that L'Hopital's rule requires us to separately differentiate the top and the bottom. That is quite different from, for instance, using the quotient rule. It is important to note that L'Hopital's rule is valid for one-sided limits, and it's also valid for limits as the value of x approaches infinity or minus infinity. So, in other words, for indeterminate limits, we have, say, our one-sided limits, and we also have our infinite limits. And again, that's provided that these limits exist. Okay, that's all for now.